Hey, good morning, pre-calc. Today we're going to talk about even and odd functions and also rate of change. But first, as we kind of introduce even and odd functions, I want to remind you back to symmetry. Back in chapter 1, we talked about symmetry. We had 3 types of symmetry that we looked at. Okay, so I'm not going to have perfect pictures, but hopefully close enough. We had our symmetry on the x-axis. Okay, we also had symmetry over the y-axis. And basically what we're saying is if you fold that first one on the x-axis here, it's going to match up. If we fold this one on the y-axis, they're going to match up. And then our third type of symmetry we talked about was around the origin. So maybe something like that. And it's symmetric around the origin. All right, now, as we look at these, x-axis, if it's symmetric over the x-axis, then it is going to not be a function. And the reason why is because each x-axis does not, each x or input does not have a unique output. So let me show you in just a second. So it's not a function. It does not pass the vertical line test. You might remember that from Algebra 2. Vertical line is going to cut through at 2 spots. For example, at 3 here. 3 has a point on my graph just shy of 2 and also just shy of -2. There's 2 different points there, so it is not a function. Now, if it is symmetric over the y-axis, this is something that we are going to call an even function. And this is useful because once we find out how to tell if a function is even, odd, or neither, then just by making that connection and seeing that, you'll know that it's symmetric over the y-axis, okay? And you can have that conclusion. Okay, and the final one, if it's symmetric on the origin, then this is going to be an example of an odd function. So once again, the reason this is useful right now, it's not yet, but once we find out how to establish if a function is even or odd, then we will be able to use that information. Before we even graph it, we'll know, is it symmetric over the y-axis or is it symmetric over the origin? Now, when we're dealing with functions, we're never going to get something symmetric over the x-axis because remember, if it's symmetric over the x-axis, it is not a function. Okay, so what is an even function? An even function is when each of the terms have an even exponent. So I'll say all terms have even exponents. And what I mean by that, these are all examples here. So this first one, 5x squared, it's to the square, so that's even, so that works. This 8, I know it doesn't have an exponent, but technically, if it has no x, it is the same as x to the 0 power, okay? Which for this, we're going to consider as even, because it's 2 away from an even. This next one, x to the 4th, that's an even term. That's the only term, so we're good. This last one, x to the 6th, 6 is even. X to the 2nd, 2 is even. 1 has nothing, but remember we could pencil in here 1 times x to the 0, so we're good because 6, 2, and 0, they're all even. So these are even functions. That means if we would graph these, all 3 of these would end up being symmetric over the y-axis. Now, odd functions. That instead is that all terms are going to have odd exponents. And so if we look at this first one, we've got x to the 3rd. Then we also just have this plus 2x. Remember, 2x, that's the same as x to the 1st, okay? So if it has x, it means the same thing as x1. Okay, so this first one was odd because it was x to the third, 3, 2x, which is the same as x to the first. This next one's odd because 10x to the seventh, the 7 is odd. This last one has 3 terms again, but 5, 3, and a 1 all are odd, so it's an odd function, which tells us, before we even graph these, if we would graph these, they're going to be symmetric around the origin. Okay? So now, our next example here. What if it's neither? If it's neither, that means that it's got a combination of even and odd exponents. So if we look at this first one, and this first one would be easy to consider odd because I know there's a 7 here, there's a 1 there, there's no term there, but remember if I wanted to, I could say 11 x to the 0 because there was no x, so then it's odd, odd, even, so in our case that is going to be neither. This next one, x to the 6th, so even, x to the 3rd is odd, so that's not going to have it. X to the 2nd, so even, x, odd. Once you get, you don't even have to look at that last one, but that's just a 4, that'd be x to 0, so it's not going to work out. And the reason this is valuable, if we get neither, then we know it can't be symmetric, okay, over the origin or the y-axis. So now we're going to go ahead and try to decide, I've mixed them up, decide is the function even, odd, or neither. So we look at this first one, 5x to the 4th, that's even, minus 7x to the 2nd. Both terms are even, so we know it's an even function, which, before we even graph this, we'll be able to tell it's going to be symmetric in some way over the y-axis. Okay, this next one, 3x plus 8, so the x, that is odd. If it helps you, you can put a little 1 there. This 8 is technically 0, so it is going to be neither because they do not match up. Okay, our next one, x to the 5th, that is odd right there. This next one, still x to 0. Once again, we get neither. And our final one, there's only one term here. It's to the 1st, so that is going to be odd. So this concept is definitely new. It's not that challenging. If you're not understanding what I'm saying, maybe go rewind and watch this the last few minutes a second time. Because I think once you grasp it, it's not that difficult. It can be very helpful, and then it helps us to see, are these functions going to be symmetric over the over the y-axis or the origin. So that's the use of this. But go ahead now and flip it to the back, and we're going to talk a little bit about average rate of change. Okay, so slope. Another word for slope is the rate of change. Like in this case, it looks like it's up 1 over 3, up 1 over 3. And in this case, it's consistent. If it's a line, it's always going to be a consistent change. However, on this one, the slope is not consistent. Here it's negative, then here at the bottom it's going to be 0, and then it slopes and starts going up. Okay, so if we are asked to find the average rate of change, we're going to do so by plugging into the function. So we'll take f of b and subtract f of a, and then we'll always divide by the difference of b minus a. So what we mean by that is if we're finding the average rate of change of f of x equals 2x squared from 1 to 3. Okay, the first number, that's going to be our a. The second one will be our b. We plug those in. Okay, so we're going to have whatever f of 3 is minus f of 1 all over 3 minus 1. So it's kind of up to you how you use your space. I'm going to go ahead and find what f of 3 is over here. So that'll be 2 times 3 squared. 3 squared we know is 9, so that's 2 times 9, which gives us 18. Then f of 1 is the same as 2 times 1 squared, which 1 squared is just 1, so that's going to be 2 times 1, which gives us 2. Okay, so now we can plug all this stuff in. So we're going to have 18 minus 2 divided by 3 minus 1. 18 minus 2 gives us 16, 3 minus 1 is 2, and our average rate of change is going to be 8. So what I mean by that is the average rate of change of the function from 1 to 3 is 8. And we'll look more at what these mean in terms of graphs, but for now, we're just trying to find a number that's the average rate of change. So our next one here, find the average rate of change from 0 to 4 for the function f of x equals x cubed minus 2. So in our case, whatever is lowest is a, and then that's our b. So we know it's going to be f of 4 minus f of 0 all over whatever 4 minus 0 is. So over here I'm going to do f of 4, solve for that. It's going to be 4 cubed, whatever we get, minus 2. So 4 cubed means 4 times 4 times 4. So 4 times 4 is 16 times another 4 is 64. Minus 2 gives us 62. And now let's also do f of 0. So that'll be 0 cubed minus 2. 0 cubed, 0 times 0 times 0 is still 0. Minus 2 gives us negative 2. So now we'll plug this in. We get 62 minus negative 2. Okay, divided by 4 minus 0 is just going to be 4. So minus negative 2 adds that, and we get 64 divided by 4, which our final answer is 16. All right, so we've got one final one left, and this function is a little more difficult. It's 3 times the square root of x. Okay, find the average rate of change from x equals 4 to x equals 25. So once again, the lower one is our a, higher one is our b. So now, it's always f of the b, so f of 25 minus f of 4, all that divided by b minus a, or 25 minus 4. So over here, I'm going to do this. It's going to be 3 times the square root of b, so that's 25. This is, sorry, I forgot to put this f of b. And 3 times the square root of 25, which the square root of 25 we know is 5. Okay, so 3 times that 5 is going to give us 15. Okay. And now for the next one, the average rate of change for f of a. So instead of a 25 in there, it'll be a 4. Square root of 4 gives us 2. So 3 times 2, which is 6. So now, a couple of reminders also. If the square root is already on there, it's only the positive answer. The square root of 5 or of 25 is just 5. The situation where it can be negative 5 is when we're solving for x and we have to take the square root, because either one could have happened. So if you're not understanding what I mean, I'll continue to talk about that more. But in our case here, it's going to be the positive version that we want. So we got our 15 and our 6. Those go up top. So 15 minus 6. And on the bottom, 25 minus 4 is going to reduce to 21. And then 15 minus 6 leaves us with 9 over 21. We're almost done. Here we got to reduce what goes into both 9 and 21. And hopefully the answer you get is 3. 3 goes into 9 3 times, goes into 21 7 times. And that is our final answer. So once again, a few new things today. Definitely some new concepts that you probably haven't seen before. So take a look back through the notes as you're doing the check today. Make sure we get that done. And please let me know if you have any questions. Talk to you later. Bye.